Hello, everyone, and welcome back to another episode. Uh, been doing this after quite a long time. So, first of all, before we move ahead, if anyone can hear us or if anyone has joined us live, if you can just drop in a message saying hi, where you're joining us from, that would be helpful. Just so that we know that we're not just talking to ourselves in the void, and there are people actually listening to us. We'll just wait for a moment, Michael, just to give people some time. There's about there.
There
There are
we
some,
go.
yeah, there's at least one person joining us. Hi, Hari Guru Murthy from India, joining us on YouTube. Hi there. Okay, so I think at least that well, there is at least one person. Others will join in a bit. So, Michael, if you can just start by introducing who you are, that would be helpful.
Yeah, so I'm Michael Lanham. I've been working in the AI ML space for about 30 years, primarily a lot of data science. Through my career, I've managed teams up to 80 people in size, research groups and stuff like that. Um, a lot of data science, as I mentioned, actually some evolutionary algorithms very early on I was very successful in. And then about 2014, started getting heavily back into deep learning, wrote several books for Pact on deep learning for games and deep learning applications, and then O'Reilly as well. And then I wrote a book called Evolutionary Deep Learning for Manning a number of years ago, which was a combination of evolutionary concepts matched with machine learning concepts.
Hmm.
And that did reasonably well. It was a new concept, ways of optimizing deep learning systems. Then from there, about 2023, the whole sort of AI revolution started to kick in, and I started playing with, GPT 3.5 and this thing called agents, and I started building these agentic systems for at work and sort of personal stuff. And people thought I was crazy because these agent concepts would never go anywhere. There's no way we're going to ever give people or give machines access to everything and allow them to do everything. It was just totally unheard of. And then so I decided, well, might as well go and try and write a book about this. And Manning signed us up. And just over time, I mean, when the book was published in 2025, the first edition, it was the year of the agents. So it became really popular.
Hmm.
And almost less than a year after the first edition was released, Manning approached me and said, well, there's a whole bunch of new stuff going on with agents. The book's a little dated. Because really the book was dated because I had introduced a lot of core concepts of how even people need to approach and understand agents. And so for the second edition, it's almost a complete rewrite. I rewrote the second edition with a lot of fundamentals and architectural principles in mind for agentic systems,
Hmm.
things people could take forward and then use throughout how they're building agents even after the fact. So it's really more of a principles book, where the first one was kind of just an introduction even to the agents concept. So I would say there's maybe half a chapter from the original book that's still in there, and otherwise almost the whole book's completely right. So
Amazing.
and AI Agents in Action. The second edition will be my 12th book, and I'm currently working on my 14th book for Manning called Self Improving Agents.
Yep.
And we're going to the next step in actually letting agents improve themselves.
Thank you so much, Michael. And for people wondering about this book, there's also a ticker going on at the bottom over here. Two people have a chance to win a free ebook of the same book that Michael is talking about, uh, AI Agents in Action, second edition. All you have to do is just comment hashtag AI, and we'll do a couple of raffles. One will be in the middle of the session, and one towards the end. Um, there are quite a lot of people who joined us. There's Ramasamy on YouTube. There's Ronald who's joined us on LinkedIn. Hi, Ronald. There's a very old friend of mine from university. Hi, David. David was from my university, Bangor. Welcome, David. Ronald has also joined us from YouTube, both the places. You can comment hashtag AI from both the places and try a chance. Uh, there's someone on YouTube inquiring when will the second edition is scheduled. Oh, it's already in early access. It's releasing tomorrow. So the full book publishes tomorrow. We're doing this book launch session over here to answer all the questions that you may have about AI agents so that Michael can answer them for you. Uh, there's already someone who's taken the lead and commented hashtag AI. please go ahead and comment hashtag AI, and we'll do a couple of raffles for people to win the ebook. So, Michael, while we're waiting for people to ask their questions, and if there are any questions, please pop them in the chat, and we'll pick them up, and Michael will answer them for you. You answered the most important question that I wanted to ask you. What is different between the first edition and the second edition? So let me move towards the community pain points. Uh, I've seen a lot of people, they build an impressive agent demo, but struggle to make it reliable. What is the biggest gap between a working prototype and a production ready AI agent?
Yeah, so the biggest gap that I find in most people's systems, and even just sort of people come to me and said, "Well, here's my system, and this is how it's working," and so forth. The first question I ask them about is, "What? How are your evals working? Right? How are you testing? How are you making sure that you establish some sort of baseline?" And this is becoming really prominent right now, but it's something I addressed, like, in my book heavily. In my book, I have the 5 layers of agents. The top layer being evolution, evaluation, and feedback. So evals being sort of the top polish that you would need to go to any production system.
Mhm.
And it's becoming very prominent, and a lot of people are looking at eval systems and building evals for agents, and understanding that, in fact, you have to have evals for these systems, and you have to have these evals running constantly, not just for the positive cases, but for the negative cases, red teaming evals, all these sorts of things that you want to introduce, especially for production systems, and production systems that are B2C, business to consumer, where it's just anything goes. You have to be quite careful there.
Amazing. So again, just a reminder for people, if you have any questions for Michael, please pop them in the chat. Until then, I'll just keep asking him my questions that I have. And for your benefit, for anyone joining in late, I'm trying to pop them up on the screen as well so people can see them, what these questions are. So there is another question that I had, Michael, among the many of the questions that I have. I'll pop it up on the screen and then read it out. So when people say AI agent, they often mean very, very different things. You know, so how do you define an agent in the book, and what should developers stop calling an agent?
Yeah, so a lot of people, I think, are still building systems where they're just calling an LLM to do something, and it comes back with a result, and they're calling that an agent, and that's incorrect. Really, when we think of agents, we're really thinking about an entity that has agency, right? It has the authority and the decision making ability to
Mhm.
go about and do a bunch of tasks to complete a goal. And really, when one of the big distinctions between an agent and an assistant is, an agent, you're giving a goal for it to complete. An assistant, it's usually you're asking a question, or it's a single sort of interaction. Whereas an agent, you're giving it that goal, it reasons and plans out how to achieve that goal, and then undertakes tasks using tools to produce the results of that goal. So yeah, big difference. And like I said, a lot of people effectively use what's called prompt chaining, or just prompting and getting responses back and thinking that's an agent. And that's not really an agentic system.
And what do you reckon they should stop calling? What should developers stop calling an agent?
What should they stop calling it? Well, if they're just calling an LLM and it doesn't have tool use and it doesn't have autonomy, that's not really an agentic system.
Okay, perfect. I can see another person has added in Victor hashtag AI. This is for the raffle. If anyone's wondering, there's a ticker going on at the bottom, so you'll understand why people are commenting hashtag AI. It's nothing out of the ordinary. And we've got a question from Joe on YouTube. Joe asks, silly question, but does Michael use AI, example Copilot, to write his agents and even help write the book? I prefer to still do a lot of my work manually.
Yeah, so for the second edition, no, I didn't use any agents. It's still kind of old school, using a lot of my just writing stuff, and that's a preference by Manning, by the way. As much as we're sort of promoting agentic use, it's really, we want to make sure it's got the real strong human touch. Um, for myself, though, when I'm working and I'm working developing code and stuff like that, I will often build with agents. My favorite tool right now is Claude Code, Fable 5. Well, I'll break it down and construct a plan with agents and building these things and coming back. But I've used agents as far back as 2023 to build these code applications, and I've been doing this for quite a while and understand. You just have to be careful, and there's ways that it can run away from you, right? Like I hear all the time, I'm going on Reddit, and people are complaining that their Fable 5 usage is gone because they let a bunch of agents go off and do something. So you do have to be careful when you're using agents to make sure that their goals and instructions are pretty clear, well defined, and I often tell it to just go so far and then stop and come back, and we'll re-talk about and regurgitate and reconstruct a plan. Allowing them to go fully autonomous, I mean, that's okay if you've given them a really good plan and they can do that work and they have a good understanding. You've given that sandbox. But if you don't, be prepared to expend your usage. That's really the big takeaway of it.
Speaking of autonomy, Jade Flawn on YouTube inquires, what percentage of your work is done by AI?
So for my job at where I work as an AI architect at Brilliant Harvest, where we produce a help desk support agent for the agricultural equipment industry, a lot of it. So I write a lot of stuff using Claude Code and other things. For writing books and stuff like that, I do curate a lot of information, build tools, build code and stuff with AI. But when I'm writing, it's all personally me. I write, and then I'll use tools like Grammarly, for instance, to sort of polish and tune up my grammar and all those other bad habits you pick up. But that's about it, yeah.
The language dependency. I think you've answered, you preempted what Jade was leading on to, and you answered that as well. The second part was about writing and developing is done by the book. So while you're waiting for more questions, I think I'll pick up another question that I had. Like many developers get stuck after basic prompting, and I think we've experienced that while we are working with AI as well. So, what core components should they understand before trying to build a serious agentic system?
Well, it's really that autonomy piece, right? It's the agent, meaning agency, is really giving them the ability to do and work with and use tools,
Hmm.
which makes them fundamental sort of agentic autonomous systems.
Hmm.
So typically what I recommend, especially in the book, is like we introduce a couple tools, easy tools to understand and how to use. You prompt instructions around those, and the
Yeah.
instructions are such that you're not telling it to do something, you're telling it how to handle or achieve a goal or a class of goals, right? So um, you instruct the agent how to do its work or how to behave given a question or a goal, but you're
Hmm.
not telling it to do something. You're essentially bounding the box in which it should work in and
Yeah.
what that pattern looks like. And sometimes you might want to be quite explicit to say, well, you always want to use this tool here and then determine from the results of that this, and this.
Mm.
And sometimes you might want to be a little more loose. Again, the best way to determine what those boundaries are is to have a good set of evals,
Yeah.
meaning what are those questions and what are your expected results from those questions. Even early on building the system, right? Like if you don't have that sort of basis, then you're really you could be building anything. So
Yeah.
really establishing those core set of evals can really help you build any system.
That's a good way of thinking of it. Like, yeah, metaphorically thinking, if you're actually, you know, laying a foundation for a building, if it's going sideways, it's definitely going wrong. You need it to go vertically upwards.
Yeah, yeah,
Good way of
exactly.
thinking. Uh, Ronald on YouTube inquires that I notice you use OpenAI agents framework in the book, at least in part. Why this choice, and are other frameworks discussed? Example, pedantic AI, agnostic, so no framework, etc.
Yeah, so I used the OpenAI framework, which was actually quite bare bones when I started writing the second edition. I would have preferred maybe actually no framework, but I don't think there was enough really. Light LLM, for instance, or Light LLM, for instance, wasn't really sort of popular at that point. But if anything, I would have used no framework. And what I'm generally recommending to people now is to, if you don't need to use a framework, you don't necessarily have to. And there's enough tools out there, and just using Fable 5 or other patterns that you can actually build your own really sort of agentic systems because the models are much better and the APIs that you're calling are much better at handling all the rough work that we used to have to handle, like tool calls and structured JSON and all these other things that a good framework supported. that you didn't have to worry about. But now they're all sort of ubiquitous, and I generally recommend, if you can, go to no framework. But if you do need to reuse a framework, use the lowest one or the simplest one you can.
Thank you. And yeah, Ronald was quick to reply, 100% agree with that. Thanks, Ronald. So Joe on YouTube inquires, what's the best approach and book for beginners to get into creating their own agents? I hear there's a book called AI Agents in Action.
Yeah, I was going to recommend mine, and really, I'm recommending it because it's really covers a lot of the core foundational principles and really goes over the basics. There is a few things missing. I didn't heavily go into skills, which really weren't a thing. Like they're just really recent, but they've become really popular.
Yeah.
But that doesn't mean that you couldn't sort of overlap that sort of understanding into what the book covers. And maybe there might be a third edition that goes into a little bit of that. But yeah, my book, and I think there's a few others. I would really sort of work on the core principles, though. I think a lot of people expect to just jump into agentic development and start using agents. And I think you really should understand what the basics are of how to build an agent, how to sort of construct those prompts of the instructions and role, to building up what are the pieces of the system, how to build a proper set of evals, for instance, how you can actually tune reasoning and other things like that. And I think those, you want to make sure that your book covers those principles.
Thanks, Michael. And Joe, why not just comment hashtag AI and try your luck? Probably you might just win the free ebook. There's another question from Jade from YouTube. Hope you also use open source local models in the book about agents in AI, because I think we need to work multimodal, sometimes online, sometimes local AI.
Yeah, so there is a place for local LLMs, especially in my self-improving agents book, where I do a lot of iteration and showing how systems iterate through time to get better, essentially. So there's a lot of calls, and there's not necessarily a need to use foundational models. So local LLMs do have a place, and I have a big suspicion that they will become more prominent in the next couple of years. A lot of people will start running using LLMs on their systems locally as memory gets maybe a little more cheaper at some point in time. But I do think local LLMs on your phone, on your computer, and stuff like that will be the thing of the future. So using them now to build agents is certainly very useful, and a bunch of them, the LLMs that you can run locally on your machine, are actually very good agentic models. Wasn't necessarily the case before. Now most of these models are designed to be agentic, so they sort of follow that loop pattern that you've heard about or people talk about often. Before, that really wasn't a pattern that a lot of LLMs would follow, but now they do, so they become really good agentic workers, meaning they can use tools, they can do stuff on the machine. So I do recommend local LLMs, but there still is a bit of a hardware requirement, but I think that's going to go away in a couple of years.
Yeah, we've been seeing quite a bit of traction for one of our latest books on local AI on Apple MacBooks, and that's been doing really well. And yeah, people have been appreciating it a lot on Meep. Yeah. So the next question is from me. So tool use is one of the most exciting parts of agents, but also one of the riskiest. How does model context protocol change the way agents connect to tools, data, and external systems?
Yeah. So Model Context Protocol, when it first came out, was a fantastic thing for agentic developers because previously we would have to essentially write a bunch of code to connect to the API, use the API, understand that how we wanted to use the API, and then build that into our agents, right? So there was a whole bunch of plumbing that you have to do for every tool. So you wanted to connect to PowerPoint or Word or whatever, you had all this additional tooling, and you had to support that tooling. And if something changed, and you wanted to do something different, it was quite complicated. MCP changed all that, made it a lot easier, which is good, but it's also bad. A lot of people now are connecting to multiple MCP servers, or they're just connecting to an MCP server and they're letting their agent run with it. That's okay if you're just building something and you're working to explore something, but it's not good for a production system or any system that you want to rely on. And that's because oftentimes MCP tools or tool connectors aren't really developed for an agent to work through and use in a workflow, but also there might be security concerns. Like some MCPs may not have, restricted sort of areas of where the tool should be used or not used. Like there might be pieces of the tool where it allows you to read and write. Like a bunch of these tools might allow you to read and write. So if you're giving an agent to that and telling it to never write, that's not a good security
Yeah.
practice, right? You want to make sure that you not even include those tools in the agent and it only has read access, for instance, of the tool that you're using. So I think a lot of people, we find MCP to be really, really handy, really easy to connect to and build systems, but it also opens up a lot of security vulnerabilities because you're not understanding what all the tools are or how they're capable. You're also introducing a lot of overhead sometimes, especially if there's a lot of tools and there's heavy tool descriptions. So you always have that overhead context. And then there's security, right? So where I work right now, we have an MCP connector connects to ADO and allows you to read, write. ADO meaning Azure DevOps. So essentially the Jira, backend tool. It allows you to read and write, and you can send an agent to sort of do all these things. And you have to be very careful because that agent has the ability to write things or change things. And if that user using that connector has admin privileges, it could do all sorts of damage and things like that. So these are things you have to really understand and be careful of. MCP is a great tool, but it also, has a number of security issues, not just in the connectivity, which a lot of people maybe not even necessarily use security overhead like OAuth or something like that to connect, but actually the tool itself or the pattern itself could be very unsecure that you need to be careful of.
Yeah, I'm just thinking about the overheads that it would create if someone accidentally gives MCP access to a legacy system and it goes into the legacy systems and starts rewriting the code in there. There are so many issues with them already. Oh dear.
Yeah, that's one way to look at it. Yeah.
Yeah. Um, Thanks, Victor, for commenting on LinkedIn. I was getting a bit worried that people on LinkedIn are not able to comment, or at least I'm not able to see them. So, Victor on LinkedIn inquires that don't know if this question makes sense, but when building a full solution, how do you determine what is better situated in a smart MCP gateway and what to relegate to the agent? From experience, where is it best to maximize the context?
Yeah, so when I'm developing, so I think your question is related to how much should I be using MCP or how much should I be using tools within an agent? Um, a lot of times when I'm building systems, I will allow an agent to have access to every tool. We'll run through, we'll test our evals on that, and we'll determine. So if there's a particular set of tools, for instance, that are always called all the time, then it often makes sense to break those tools away from the agent, call those tools as if you're calling an API, for instance, getting the outputs of those tools, and then feeding them in through the agent as sort of input. So essentially, making your agent as more deterministic as you possibly can. So, we've talked about giving agents agency, giving them tools, letting them use tools, have all this autonomy. In some cases, just to make your system more production efficient, if they're always using the same tools, you might want to take those tools away and then just sort of call them off to the side and then produce that input into the agent. But that's, again, the best way to track that is through observability, evals, being able to track telemetry, and et cetera.
Thanks for that, Michael. So Joe on YouTube inquires that do I need a powerful PC to run more than one agent? I have NVIDIA 5600T, 16 gigabytes. Is this powerful enough for running multiple agents locally, or do you recommend developing it in the cloud?
So with just the spec that you have here, I would recommend developing the cloud. There is a bunch of systems now that have unified memory that'll run LLMs. Strix Halo, for instance, and some other machines, and Tushar just mentioned Booka Manning that uses the MacBook. So there's a lot of good platforms of that. 16 gigabytes is a little low, not just because it's a small model, but that small model is probably not going to have a high token speed, and you really need to have, if you want anything done within a amount of time, a decent token speed, right? Like time to first token or just your token throughput essentially. And that's really one of the one of the restrictions of local LLMs is you don't get those high token speeds. So if your agent is using a bunch of tools and it's working through things and needs to make a bunch of tool calls or do anything, it's going to do it really, really slowly. So just something to be aware of.
Yeah. I think we are at the halfway mark, and I can see that there are a few comments which have come in. Thanks, Victor. So let's do one of the raffles now, and yeah, and we'll pick up the questions again. So anyone who has more queries, please keep popping it in the chat. We'll pick them up shortly. And Michael, this is your time. If you want to grab a sip of water, please do that. And I'll share my screen, and we'll do the first raffle live as I promised. Just let me know when you can see my screen, Michael. Can you see it?
No.
Oh, I haven't shared it. Okay, there, it'll come up now. Perfect. Okay, so here there are 5 people who added hashtag AI to the chat on different platforms, and I've clicked on draw. Let's see who our first winner is. Okay, so Jade Flawn on YouTube. Congratulations, Jade. You're the first winner of the ebook from Michael, AI Agents in Action Second Edition. If you can get in touch with me on LinkedIn or contact our Manning Publications LinkedIn page, uh, I'll get access to your book. Congratulations, and do not be disheartened, any others. There is another giveaway. Keep commenting hashtag AI and keep adding your queries to the chat. And for us to continue, I have another question, Michael. So I'll just pop it in the chat first and I'll share it on the screen. So multi agent systems sound powerful, but they can also become chaotic, as we discussed earlier as well. When should someone use multiple agents instead of one well designed agent?
Yeah. So typically, you get into sort of producing an agent. You're building an agent. It's got a bunch of tools. You've aligned it to sort of solve maybe a set of goals that equate to a set of evals, and that's going well. And you add another couple sort of evals and goals that you want it to handle, and maybe some more tools and so on and so on. So at some point maybe the agent's got 25 tools that can handle 10 different classes of goals and stuff like that. Well, at that point, the overhead for every time you're making a call for that agent, it's carrying with it 25 tool descriptions, right? It's carrying with it all those goals, which are probably some used prompt. And there is prompt caching that sort of alleviates this, but a lot of cases, it's going to get tripped up. It's going to get miss and match goals. Some goals might be contrary, for instance. In those particular cases, then it makes sense to break the agent up into sort of pieces.
Yeah.
That could then be delegated a number of different ways. So in the book, I talk about a number of different multi-agent system patterns, from an assembly line pattern where you just have one agent processing something and then producing something and producing something, to agents which are orchestration, right? Like if you use Claude Code or any of the more popular tools, they'll have like the orchestrator agent, which spawns off about 10 different other agents, or maybe 20, any number of agents that go off and do tasks. And when they're done those tasks, they feed back into the central agent. So that orchestration pattern is becoming very, very popular. A lot of people are making very good use of it, Claude being one of them, and all these other tools, for instance. And that seems to be popular, but oftentimes the assembly pattern works really well too. It really depends on your use case, right? So, but the lots of different variations of multi-agent systems. Yes,
Makes sense. Thanks, Michael. Jade has another question. Firstly, Jade, congratulations. You've already won the book. Do get in touch with me. Did you recommend the AMD Ryzen 9 AI Max 395 with 128 GB unified memory, or the Mac with 64 GB?
I would recommend the 128 gigabyte unified memory. I I think you could probably run some good, really agentic systems with a good token speed that could be really powerful. Don't expect foundational coding going on, but if you have a system that's just doing or building or working with agents that are using tools for whatever application, yeah, that's a pretty good system.
Thanks, Michael. And Jade, at least got, yeah, congrats again. You've got the message through that you won the ebook. Yeah, I'll wait for them to get in touch with me. So yeah, I have another question. So planning and reasoning are where agents often look smart until they fail unexpectedly. What are the most common reasoning failures you see, and how can builders design around them?
Yeah, so typically in terms of building agents, we often actually turn the reasoning down in the model. We'll often actually reduce the amount of reasoning. Um, and that's because you don't want the agent reasoning, like if you're giving it a specific goal, you're giving it a specific set of tools, you're giving it instructions how to use those tools and plan out and essentially reason,
Mm-hmm.
it becomes far more efficient, right? If you're giving the agent where every time it's sort of approaching and understanding how to use a tool and then goes into this reasoning loop of thinking now how to use the tool and so forth, it can get really inefficient. Now, if you've ever used Claude Code again as an example, and you've let it run off and do a whole bunch of agents, and it's doing all these things, and I think I've had it spawn maybe up to 130 agents, as an example, right? It's going off and doing all these things, and then sure enough, before you know it, your usage is gone, and you're like, what the heck is going on? Um, so in terms of efficiency, when you're building agentic systems for production, applications, you want to control the reasoning. You want to know how much the agent's reasoning. In a lot of cases, you really want to be strict in control. You want to turn those reasoning levers down and understand how it's doing those things. And by doing that, then you have the control, and using your evals, you can make sure your agent doesn't go off the rails. If you don't do this, you can almost assuredly expect that the agent will go off and do some reasoning effort,
Yeah.
and it'll just disappear for a while and then come back 2 or 3 minutes. Like, and in production systems, in agentic production systems where you're having users ask questions and expecting results, your latency is usually under 30 seconds. Like we have a couple of agents that we built on my side, and it's under 30 seconds. Where as most developers, you're building something. If it goes off for five minutes or an hour, it's kind of expected. But that's really not the mentality we need to be sort of passing on to our users. And users will have far stricter requirements in what their latency is.
Yeah. True. Thanks for that, Michael. And I think it's turning into a hardware requirement podcast. So Rajiv on Facebook inquires, is Mac Premium worth it, or Go Max on hardware with non-Mac platform and Linux?
I'm not typically a Mac guy, but I think of the Mac. The Mac is a unified memory platform that allows you to push a large language model onto it. I've seen that very successful. I'm going to go back to the book that Tushar I just mentioned a while ago. Maybe you want to repeat that, Tushar. I think the audience and honestly, I'm not surprised, because I think just based on the whole sort of model fiascos we've seen in the last month, people are really starting to look at the local LLM and how they can sort of start owning their own LLM without it having to sign up for an API and pay these outrageous usage fees in some case.
Yeah. The book is called Building Applications with Local AI Models on a Mac. And anyone who is connected with me or follows me, they would be aware because I've been adding a lot of videos about the book lately. I did a podcast with the author, and I had a lot of content to post on my LinkedIn. Uh, that place feels very familiar where Rajiv stood. I have a picture in the exact same spot in Amsterdam. Is it Amsterdam? Is it Venice? I don't know. Anyway, sorry, I just got derailed by that picture. But yeah, Rajiv, do check that book out. Building applications with local AI models on a Mac. It's from Manning. So yeah, so Michael, the next question that I had was, memory and RAG are often treated as add-ons. In a useful agent, how should memory, knowledge retrieval, and context management actually work together?
Yeah, well, so typically, I think a lot of people are building RAG agents, retrieval augmented generation agents, where they're using sort of knowledge, some sort of backend knowledge systems that they want the agent to sort of explore and understand and use. And those are quite popular. We've seen a lot of those. Um, and it's almost fundamental that anytime you're building an agent, you're probably going to power it with some sort of backend knowledge base. So that's almost ubiquitous now. Memory. definitely is becoming more popular, especially for production agentic systems we're developing. It
Mhm.
allows you to be more personalized with the user, understand maybe potentially facts about them or situations they've got into in the past. The one problem that I often sort of want to wave in front of saying memory is great, but it also you have to be aware of what's coming into the memory and how it's being used. So it's easy to poison some memory. The
Mhm.
user has really a bad experience, or something happens, or something unexpected happens, or the response of the agent is actually incorrect. That can sometimes poison the memory. So you have to have a good sort of memory pruning system where you're evaluating those memories at a regular basis and then pruning, potentially bad memories. It's the one sort of system that can be really useful, but also can be really problematic. You have to be aware of sort of the bad and the good of memory. And that one piece is that memory can be easily poisoned. So you just have to make sure that you work around
Yeah, I can see Rajiv has added another comment saying that it almost cost a kidney and a quarter liver. And Rajiv, you would be surprised. I was just having a look at your comment and then the book. Right in the first few pages of the book, there's a section called What Will You Need? And it says a recent Mac, at least 8 GB of RAM, 16 GB or more is recommended for larger AI models. Just check the book out. I'm pretty sure you'll find it interesting. Yeah, if you still haven't heard the name of the book, just drop me a message on LinkedIn or drop a message on the Manning page, and we will share the name of the book with you. Uh, yeah. So Joe on YouTube inquires, does Michael ever consider how agents run in terms of concurrency or multi-processes, task runners, and queues such as Rabbit, Kafka, or do even the lower level libraries cover these problems?
it. Yeah, so I think you're asking about sort of distributed agent processing and if agents can sort of work on a queue system like RabbitMQ or Kafka. They certainly can. We can certainly develop a lot of agents where it could even be in some cases other agents driving other agents by dropping messages on queues where other agents pick up those messages, process them, and put the results back in the queue where other agents then would process them. Or if you have a distributed system where you have a lot of users on your system, the obvious thing is if a user asks a question, it goes into the queue, it gets served by an agent, and then processed and pushed back out. So, yeah, very much not talked about in a lot in agentic development, but definitely RabbitMQ, Kafka, or any sort of message queue would be very useful.
Thanks, Michael. And I think the next question is something that we've spoken about quite a bit so far in this session, that evaluation is actually a major community pain point because the agent behavior is really hard to test. So, what should teams measure to know whether an agent is improving or it's becoming dangerous?
Yeah, so again, when you're building those evals, one of the things around building an eval is a rubric, right? A rubric is a scoring guide that you can use, or an
Yeah,
agent or an LLM can use to score the output. And
right.
then normally people sort of, when they think about writing these evals and automating these evals, they look at LLM as a judge. Um, and LLM as a judge by itself, looking at a single output of an agent and a rubric, can give you a sort of guide on or relative guide on how things are progressing, how the agent progressing. But ideally, you want to always have comparison,
Right.
right? And by allowing you to compare, say, a previous version of an agent to a newer version of an agent, comparing those outputs, and then tracking if you're actually getting better or not is a better sort of contrastive comparison evaluation that you're doing. It's a
Mhm.
lot easier for an LLM to gauge if between two items if this is good or bad um, than to say, well, this is just good based on this rubric. So definitely being able to version your agents and then do comparisons, these AP comparisons with an LM as a judge and a good rubric
Yeah.
can often provide you a good set of evals or base set of evals that you can also then have. Like if you're expecting some sort of ground truth, like some sort of context from the certain question always should be this guide from the employee's handbook, for instance, that would be more of a ground truth eval that you can definitely test either deterministically or with a simple agent or a simple LM.
Yeah. So will it also help with sort of like building guardrails for it so that it doesn't go out of order or chaotic, or is this core metric system just to keep it on track and just to keep looking at this responsible development?
Yeah, so just really making sure that the agent behavior is consistent
Right.
and it's not doing something it shouldn't be. It's not using its tools somehow that it shouldn't be. You really just sort of got making sure that it's with operating within its bounds, right? Like, because you're giving an AI autonomy, it could be
Mhm.
doing anything. So you want to make sure it's operating within the box you give
Yes.
it and what those tools are and what those instructions are and those behaviors. Like you might have a certain type of language that you
Mhm.
want the agent to speak in. That would be sort of the role and description. So always use formal language, for instance, would be an example of that. Always use these tools and then always push out the output in this way. Or in most cases, you'll use structured output, which allows you to structure all your output, and the agent isn't really giving you any surprises. So for any sort of agentic system, I always recommend some form of structured output that you're
Mhm.
getting from the agent, and it sort of has to fill in a form rather than just spewing out a bunch of information. By filling in the form, you very much control how it's sort of how you're presenting that back to the user, right? So and I'm saying form, but it could really be a lot more complex. Like I use hierarchical, um, you know, give me a note with a note with a note, and then I can structure it the way I want to. So there's a lot of different, unique patterns you can use with structured output, which is very useful to controlling agents.
Interesting way of looking at it. Thanks, Michael. So, so deployment is where many agent projects stall. What changes when you move from running an agent locally to deploying an agentic system that users or businesses depend on?
Yeah. So a few key things. One of the first ones is latency. You build this cool demo, you've got everything working, but at not one point did you determine it's taking too long for the answer to come back, or I'm not going to be patient. Business users or users depending on these systems are used to being the Google mindset.
Mhm.
Essentially, I do a search and it's coming back within milliseconds, right? So you don't have that same freedom for a typical business user, at least now, to answer a question or respond with some sort of output in times larger than a minute, in my experience. So your latency is really critical. The other thing that I think a lot of us run into when we're sort of running these things is token usage and token cost. If you've got a heavily used system, you're going to start looking at token cost really quickly because if your agent's going off running a bunch of things, it's got a bunch of overhead that it's always using, and you're running through 100,000 or 200,000 tokens for something that should only be 20,000 tokens, that adds up really quickly, and your system gets really prohibitively expensive. And you're not going to, it's not going to be long before somebody says, "Well, we can't use this." You have to sort of cut down the token usage. So latency and token usage, I think, are the big ones because they drive cost and they drive customer dissatisfaction. The third thing is evals, right? So anytime that you're building these things for business users, or you're putting them in front of your whole company, where it's answering questions or doing something about HR, for instance, you want to make sure your evals are very strong and guiding the agent to do only what it needs to do. Like if your agent is going off and giving a bunch of information it shouldn't be giving, then that's something you need to know. And there's in the book I cover a lot of this, what needs to happen and how much sort of agency the agent has and what that looks like.
Thanks, Michael. And if someone has any more questions, please feel free to ask them. I've got my last question. After that, we'll do the last raffle giveaway. And if you don't have any questions, we'll call it a wrap. If you have more questions, feel free to ask them and I'll pop them up on the screen for Michael to answer. So here's my last question for you, Michael, in case we don't get any more. So if someone has read blog post, watched one of these demos or most of these demos that we're talking about on Google, Facebook, and tried frameworks but still feels unsure how to build agents properly, how does your book AI Agents in Action Second Edition help them move from scattered knowledge to building effective solutions?
Yeah, so really when I wrote the second edition of the book, I wanted to make it fundamental principles, right? So I wanted to teach the basics of how agents work and the most important things that you need to understand are and how to effectively sort of build um, through. So one of these examples is a lot of LLMs have reasoning built in right now. But as I've sort of discussed previously, reasoning in agentic systems can be quite dangerous, and oftentimes you want to control the reasoning. So
Hmm.
I have a chapter on reasoning and how you can control reasoning, so that you have more control on how the agent thinks and how it behaves. And that's really what it comes down to in a lot of these sort of building these agent systems is you want to make sure and control the consistency of how the agent's working.
Yeah.
Um, if the agent's just a coding agent or doing something, you can give it free reign. You can go allow it to do anything. But in a production system where the users are sort of always submitting some sort of list set of goals that determine some sort of evals that you're training against, you want a controlled and consistent system. And that's the best way. If your agent's going off and doing something it shouldn't be doing and it's racking up tons of tokens and it's taking forever, you don't have a controlled and consistent system. So, and a lot of my book teaches exactly how the patterns that you need to employ to get there and what that all looks like.
Perfect. And I think we've already got a testimony from Ronald over here. Ronald on YouTube says that the book is great so far. I have the PDF already. I like the focus on the principles. Thanks, Ronald. Uh, on that note, we'll do the final giveaway. I don't see any more questions coming up. So there's my screen. Jade was the first winner, and I'll click on draw again, and let's see who our next winner is. A bit of a drum roll, if I may. Hari Guru Ramurthy, Hari Guru Murthy from YouTube. Hari was one of the first persons to comment as well today. So congrats, Hari. Please get in touch with either me or the Manning's LinkedIn or Facebook page. Drop us a message and we'll get you your ebook. Congrats, Hari. Congrats, Jade. Uh, and thanks everyone for joining. And on that note, Michael, would you like to share any closing thoughts?
No, thank you very much for having me. This has been fantastic. It's always great to talk about the book.
Yep. And thanks everyone for joining. I'll see you soon with another episode of this. Cheers for now. Bye.